We show a visual here. Let's go A, B, C is the big one. We have point D in the middle. So this part measure angle ABD plus the measure of this other one, DBC or CBD, measure angle CBD equals the whole angle, measure of angle ABC. Part plus part equals whole. Very much like segment addition. Angle bisector. A ray or line that cuts an angle in half. Let's say this is our original angle. I'm going to guess at this. We're going to say this cuts it in half. How do I know? Because I'm going to put one tally there, one there, so that we know that they're congruent. So let's find the indicated angle measure. I know that angle EFG, the big angle, this whole thing is 130. So find the measure of angle HFG. HFG. Well, I have this part, 86, this other part that I don't know, and that should equal 130. So I've got a part plus the part I don't know, angle HFG, and that equals 130, the whole piece. So now I can just subtract 86 from both sides, and I'll know what that missing piece is. Oh. $44, that was good. All right. All right, same thing here. Wants us to figure out what the whole is. So I have part plus part equals whole. 31 degrees plus 24 degrees equals the whole thing, which is the measure of angle BAD. BAD, the big one. So this is just 55 degrees, and that tells me my angle that I need. All right, now we have some bisect questions. So the key word is bisect and then bisects. So QS bisects PQR. Find angle PQR. So he wants to know the big one. So the idea is if that's 24, this also must be 24 degrees. So 24 degrees plus 24 degrees equals the whole angle. That is 48 degrees. All right. So what do we have over here? QS bisects PQR. Angle PQR, the whole thing, is equal to 124. Find PQS. Well, if I know this angle and this angle is the same, I know this angle plus this angle is the same. So if I've got two of those, I just need to cut that in half. So 124 divided by 2 equals 62 degrees. So measure angle PQS equals 62 degrees. And if they ask me what the angle of SQR is, that's also 62 degrees. So 62, and this one right here is 62 degrees. All right, so now we have some algebra in the problems that we're working on. So in here, I know, what do I know? I don't know that they bisect. And if I read the question here, the whole angle is 98. This whole angle is 98 degrees. So I've got part plus part equals whole. So I've got one part is 3x minus 8 plus another part, which is 2x plus 6. That equals the whole, which is 98 degrees. So I'm going to combine like terms. 5x and negative 2, because negative 8 plus 6 is negative 2 equals 98 degrees. So I'm going to add 2 to both sides to get that x by itself. 5x equals 100 divided by 5. I get x equals 20. It wants me to find the measure of angle QRS though. QRS. So that's 2x plus 6. And I take this and plug it in. 2 times 20 plus 6. That's 40 plus 6. So that's 46. So I know that the measure of angle QRS equals 46 degrees. Ooh, ooh. All right, bisect with some algebra. And if it bisects, that means that this angle is equal to that angle. So I'm just going to set those equal to each other. 4x minus 10 equals negative 3x plus 130. I'm going to add 3x to both sides. It's 7x, bring down the 10, minus 10 equals, bring down the 130, 130. Add 10 to both sides to get the x by itself. So I've got 7x equals 140. X is still not by itself. It's 7 times x, so I'm going to do the opposite, which is divide. I'm going to divide by 7 on both sides. I get x equals 20. And as you know, we're almost there. I still need to find angle, measure of angle PQR. So I'm going to take that x and plug it in for where is PQR? PQR is 4x minus 10. That's 4 times 20 minus 10. That's 80 minus 10, and that is 70 degrees. So the measure of angle PQR is equal to 70 degrees. All right, there's front page of measuring angles. Good bit. So you have a couple different examples here of types of angles. We got vertical angles, adjacent angles, complementary angles, supplementary angles, linear pair. So vertical angles are angles that are when you have two lines cross, the angles across from each other, vertical angles. And then when you have two lines, I will say a line broken by another line, these two are considered a linear pair. Supplementary angles are any two angles that add up to 180. So a linear pair looks a lot like it. I'm going to write plus 180 so I don't forget. And complementary angles are ones that add up to 90. Like those two. And those don't have to be touching either. Maybe I should put these touching also, just so I don't forget. And adjacent angles are angles that are next to each other. So they don't have to be bisected, they don't have to be 90 degrees, they don't have to be supplementary, they're just next to each other. So now I'm going to use this information to help me solve this page. If I know angle 1 and 2 are complementary, that's 90 degrees, right? So that's what I should be thinking. Measure of angle 2 plus measure of angle 2 is 71 degrees. Find measure of angle 1. Well, I know that measure of angle 1 plus measure of angle 2 equals 90 degrees. Measure of angle 1 plus measure of angle 2 is 71 degrees. So I got some numbers in there. So now I know I can solve it. I'm subtracting that 71. And quickly I find out that the measure of angle 1 equals 19 degrees. Supplementary is pretty similar, but not 90 degrees. Those out to 180. So I've got measure of angle 3 plus measure of angle 4 equals 180. Measure of angle 3 is what I'm looking for. Measure of angle 4 is 27 degrees, or 26 degrees. Minus 26. So the measure of angle 3 equals 154. All right, number 24. It's got this box here, so I know that they're going to be complementary. So these are going to add up to 90 degrees. So 2x plus 1 plus 7x minus 10 equals 90 degrees. I'm going to combine like terms. So we get minus 9 equals 90 plus 9 plus 9. 9x equals 99. Divided by 9. X equals 11. What do they want me to do though? I need to find WXZ. WXZ is the 2x plus 1. So I'm plugging 11 there for x plus 1, 22 plus 1, 23. Just so people know my answer, measure of angle WXZ equals 23 degrees. Number 25, what I have going on over there is I have a linear pair. They're right next to each other, line down the middle, straight line. So here I had complementary. Here I have linear pair. And with a linear pair, what I know is that those are supplementary. So 2x minus 18 degrees plus 4x equals 180. So I'm combining like terms. 6x minus 18 equals 180. I'm going to add 18 to both sides. I get 6x equals 198 divided by 6. And x equals 333. Am I done? Nope. It says find the measure of FGH. So it says find the measure of FGH. FGH, that's 4x. and x is 33. So 132. So the measure of angle FGH equals 132. This one tells me it's complementary, so they add to 90, whereas this one says supplementary, so they add to 180. So 4x plus 2 plus 3x plus 4 equals 90. It's really just an algebra problem after you know the geometry vocabulary. So 7x, you get the 2 plus the 4, gives me 6, equals 90. I'm subtracting 6 from both sides to get the x by itself. 84 divided by 7. I get x equals, goes in there 12 times. I'm not done because he wants the measure of angle R. Measure of angle R is 4x plus 2. I'm plugging in 12. 4 times 12 plus 2. That's 48 plus 2 gives me 50. So, measure of angle R equals 50 degrees. Let's go. Same type of problem, but it's supplementary, which means they add to 180. So 6x plus 59 degrees plus 3x minus 14 equals 180, because it says supplementary, so I know they add up to 180, so they add up to 180. 6x plus 3x is 9x. 59 plus 4 is 63 equals 180. I'm going to subtract 63 from both sides to get the x by itself. And over here I get 117 divided by 9 divided by 9. X equals 13. But I know I'm not done because they want to know m. M is 6x plus 59. Plug in the 13. It's 6 times 13 plus 59. I do not know what that is. 13 times 6 gives me 8. 31, 78. 78 plus 59 equals 713. So 137. Measure of angle M is 137. Here we have angles, two lines that cross, and angles across from them. They're called vertical angles. And what I know about them is that these are going to be congruent, which means that the measurements are the same, so I can set them equal to each other. So 5x plus 11 equals 4 times x plus 6. Oh, we throw in some distribution in here. So I got 4 times x, 4 times 6. That's the most common mistake. People forget to multiply the 4 times the 6. So this gives me 4x plus 24. 5x plus 11. I'm going to subtract 4x from both sides. I get x plus 11 equals 24. Subtract 11. I get x equals 13. Oh, I'm done. No way. Okay, just said solve, find the value x. Sweet. Done. All right. Over here, let's go with vertical angles first. So I know that this one and this one are congruent. So I can write 6y minus 27 equals 105. I can add 27 to both sides to solve for x. Solve for y equals 132 divided by 6. I get y equals 222. All right, nice and sweet. All right. 12x plus 15, that is a different angle measure. So what do I know about those? I know that they up to 180, so I'm going to add these two up to 180. So 12x plus 15 is that angle, plus the linear pair next to it, which is 105 equals 180. So I'm going to subtract, no, I'm not. I'm going to combine these terms first. So combine those terms, I get 120. 12x equals 180. I'm going to subtract. Yep, I'm good there. I'm going to subtract 120 from both sides. I get 12x equals 60 divided by 12 on both sides. I get x equals 5. And I have solved second page of the review. Let's go. All right, let's go. I need let's see, red, blue. Let's do purple. Let's get this answer key for this chapter 1 test review. So give another name for the plane. This doesn't have a point on it, so I can call it plane A. Okay, but here it says plane A, so I guess I can't use that one. That seems like cheating. So I got to use 3 other letters that are on it, but I can't use the ones in the same line. So I can't use GEF, but I can use GEB. So let's do that. Plane GEB. And yes, I can call it BEG, EBG, EGB. Name a line. I've got GF, double arrows on the top. I can also write that the opposite direction. I can go GE. I can also write it the opposite direction. And I got EF. Or FE. Need the arrows, both arrows on top. Am I missing one? I could write CD if I want also. That's a line. It doesn't say on the plane, it just says a line, so I can use CD. Or I could use EC, ED. I'm going to move on. So there's a couple more. Name 2 points that are coplanar with G. So what are the points that are on here with G? I can use EF, EB, BF. I'm not naming the plane, so I can use any of those 3. So I'm going to say EF. Or I can use EB. Or I can use, what am I missing there? BF. BF. Alright. Name a segment. So I don't need the arrows on this one. It doesn't say on the plane, so I can use CE or EC. I can use GF. I can basically use everything above without the arrows on it. So FG, and then I need to have the line over the top. So I got some more. Name 2 points collinear with C. So there's C, E's on that line, D's on that line. So E and D. Name a ray, so direction matters, so I can go EF, I can go EG, I can go EC, because it doesn't say on that plane. I can go ED. I can do a couple more, like I could just say CE and go in this direction. Let's see, FE. So basically I can write these backwards because they're going in both directions. I can continue. Alright, segment addition postulate. is where you are taking two segments. I'll use this one. So you have point A, B, C. Segment addition postulate is where AB, the length of that, plus the length of BC equals the length of the whole thing. If you want to think of it as a baguette, you cut the baguette here. You got one piece of baguette, you got another piece of baguette. If you put it together, theoretically, you have the baguette put back together. I guess you glue that with butter. All right, midpoint formula. How do you tell the point in the middle? You got an x value and a y value. You're going to take the x values and add them together and cut them in half. You're finding the average. And then you're going to take the y values, add them together, and cut them in half to get the y values. You get the distance formula. Distance formula is like Pythagorean Theorem. You got a squared plus b squared equals c squared. And here, I like to write this first. I got the plus in the middle, two minuses. These have squares on them, and the square root. So I'm going to take my x's and subtract them, and my y's and subtract them. And then just because I'm going to sneak in Pythagorean Theorem right here. A squared plus b squared equals c squared. Because that can also help you find your distance. Pick which one you'd like to use. Kind of like with the midpoint formula where you could count. Alright, some pretty standard questions here. We're going to find ST, which is the whole thing. So using segment addition, I'm going to add 4 plus the 7 equals 11. Or ST equals 11. Every time with segment addition, we give you a part plus the part equals the whole. And every time with segment addition, we like to switch it up. You got a part and the whole, and you got to figure out the other part. So this part is 4. I don't know this part, but the whole thing is 22. So I'm going to take 22 minus TU, and that will give me 18, which is ST. So right there. If I want to double check, 18 plus 4 gives me 22, the whole thing. Here we have an angle bisector. How do we know it's an angle bisector? We got that tally and that tally. I'm going to write angle bisector, just so I remember. What I have going on here is I know this segment is equal to that segment. Doesn't really say what we want to find here. So let's say you need to find SM. So if this one is 19, this one must be 19. How about we do this? SM equals 19 and ST equals 19 plus 19, which is 38. And what I realize right now is for all these questions you need to find ST. So that was conveniently set up. I need to refer back to that. Alright. Now bottom of the page, using segment addition, I've got AB plus BC equals AC. Here I have AB equals 8x plus 5 plus BC, which is 5x minus 9, and that equals AC, which is 74. So I'm going to combine like terms. That's 13x negative 4 equals 74. Add 4 to both sides. I've got 13x equals 78 divided by 13. Grab your calculator or take an educated guess. It looks like 6 to me. 6 times 3 gives me 18. Carry the 1. 1 times 6 plus that 1. Okay, so I got x equals 6. But I'm not quite done. It wants me to find all of them. I already know AC, but I got to find AB and BC. So AB is 8x plus 5, and I know that the x equals 6 now. So 8 times 6, I'm going to draw a little line here so separate them. 8 times 6 plus 5, this gives me 48 plus 5. So I've got AB equals 53. There we go. Then I need to find BC. BC is 5x minus 9. I know the x equals 6. So 5 times 6 minus 9. 5 times 6 is 30 minus 9. And I get BC equals 21. Alright, next problem. Similar type. I've got AB plus BC equals AC. AB is 13 plus 2x. Looks like that's written backwards to try and trick us, but it's not going to. BC is 12. And AC equals x plus 32. No big deal. Alright, knock at the door. I'll be right back. Alright, I'm back. Let's see. So let me just combine like terms on the left hand side. So 13 plus 12 gives me 25. So I got 2x plus 25 equals x plus 32. I'm going to subtract x from both sides. So 2x minus 1x equals x, or 1x plus 25 equals 32. Subtract that 25, and x equals 7. Now I need to plug those in. I would get 1 point on the test for doing that. Now I'm plugging in x equals 7, because I have to find the rest. I already know BC, which is 12. So I've got AB is 13 plus 2x. That equals 7. 13 plus 2 times 7. 13 plus 14. And I've got 27 for AB. AB equals 27. Next one, I've got AC equals x plus 32. My x is 7, so I got 7 plus 32, and I get AC equals 39. So sure enough, if I double check, 27 plus 12 gives me 39. So I'm good to go. Next side. All right. The endpoints of Ln are given. Find the coordinates of the midpoint M. So let me graph this because I can solve it that way if I want. I've got 1, 2, 1. There's L. And then 1, 2, 3, 4, 5, 6. I don't need to go that far. So 2, 1, 2, and up 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 2, 13 is N. Find the coordinates of the midpoint. Well, if I count, I'm going from 1. I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or 13 minus 1 equals 12. And so half of 12 is 6. So if I count up 6, 1, 2, 3, 4, 5, 6, that's going to give me my point. Normally what I would have to do is also count in the x direction, but since they're both 2, they don't go left and right at all. So there's my midpoint, which is 2. So 1, 2, then up 1, 2, 3, 4, 5, 6, 7. Okay. So it's 2, 7. Right? 1, 2, 3, 4, 5, 6, 7. Yeah. Should draw my graph a little bit better, but right there is 7. So there's my midpoint. If I use the midpoint formula, I've got x1 plus x2 divided by 2, and then I've got y1 plus y2 over 2. I'm going to label these x1, x2, x1, x2. Oh wait, sorry. x1, y1, x2, y2. So x1 is 2 plus, what's my x2? Here it is. That's also 2 divided by 2. It's kind of messy, but my y1 is 1 plus my y2, which is 13. So 2 plus 2 is 4 over 2. 1 plus 13 is 14 over 2. Reduce that, and I get 4 divided by 2 is 2. 14 divided by 2 is 7. I got the same answer as if I counted. Alright, number 13. Let me graph that. This one, the numbers look a little bit smaller, so that might be easier if I graph nicely. So I've got negative 6, 0. 1, 2, 3, 4, 5, 6. And that's going up 0. So that's the first point. And then the next one is 6, 6. 1, 2, 3, 4, 5, 6, and up 6. 1, 2, 3, 4, 5, 6. So over 6, up 6. There's n at 6, 6. And here is negative 6, 0, and we call that L. So if I count from one to another, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I counted over 12. Half of that is going to be 6. So I count from here, 1, 2, 3, 4, 5, 6. It's going to put me right in the middle. So my midpoint's going to be somewhere on the middle line. And then my y value is counting up. Alright, count up 6. Or count up from here. 1, 2, 3, 4, 5, 6. So I counted up 6. Half of that is 3. So if I count up 3, 1, 2, 3, it's right there. And that's going to be my midpoint. So from here, half of it is 6. Then I'm going up half of that, which is 3. That's my midpoint between those. And that point is 0, 3. If I use the midpoint formula, I've got x1 plus x2 cut in half, and y1 plus y2 cut in half. Let me write this neater this time. That's x1, that's y1, that's x2, that's y2. Alright, so I'm going to plug those in. I've got x1 is just negative 6 plus x2, which is 6. And then I need to divide that by 2. And I've got y1 is 0 and plus y2, which is 6. And I divide that all by 2. So negative 6 plus 6, well, that cancels out. So that's 0 over 2. 0 plus 6 is 6 over 2. So 0 over 2 is just 0. 6 divided by 2 is 3. Is that what I got? Yep. The same thing I got over here. Alright. Find the midpoint. So the midpoint M and one midpoint are given, so you're going to find the coordinates of the other. This is the one that can get a little sneaky. I feel like counting is easier, but it's up to you. So the midpoint is 1 up 2, right there. That's the middle. And the other point is negative 1, 4, so back 1, up 1, 2, 3, 4. And that's the midpoint, so the other one's going to be over here somewhere. So if I count from here to there, I'm just going to repeat it. So if I count down 1, 2, and then, so I counted down 2, and then I count over 1, 2. In that direction, I'm going to do the same thing from here. I'm going to count down 1, 2, 1, 2. And that's going to be my other point. So what point is it? From the origin, that x value is 1, 2, 3. And I'm going up 0, so that's 3, 0. That's my other point. Let me verify that using my formula, my midpoint formula. So this side, I'm going to have x1 plus x2 over 2 equals whatever the x value is of my midpoint. So let's see what that looks like. So x1, let's call this my x1, my y1, this is my xm, and my ym, my telometer. So my x1 is -1 plus an x I don't know divided by 2. That equals xm, which is 1. To solve for this, I need to get rid of 2 in the denominator, so multiply the whole thing by 2, multiply the right by 2. This cancels out, which is why I did that. I've got -1 plus x2 equals 1 times 2 is 2. Add 1 to both sides, and I get my x value equals 3. Okay, so there's my 3. I got to do the other side now. So y1 plus y2 over 2 equals my y value of my midpoint. So y1 is 4 plus a y I don't know over 2, and that equals the y value of my midpoint, which is 2. So now I need to solve, get rid of 2 in the denominator, multiplying that whole thing by 2, and this side by 2, so that those cancel. And I've got 4 plus y2 equals 2 times 2, which is 4. Subtract 4 from both sides, and I get that my y value equals 0. So sure enough, if we look up above, I get 3, 0 is my point. Nice. Alright, now I'm going to do the same thing over here. I've got, let me label them first, x m for my midpoint, y m for my midpoint, x1, y1. I like to graph these, so I notice that they're both positive, so I'm going to focus my graph over here. So my midpoint is 3, 7. 1, 2, 3. Over 3, up 7. 1, 2, 3, 4, 5, 6, 7. There it is. My other point is 1, 1. So over 1, up 1. Oh man, somebody made this so that it would be difficult. So I got my point here, my midpoint here, so my other point's over here somewhere. I'm still doing it. Alright, so x value or x direction, I'm going over 1, 2. So I went over 2. How far do I go up? 1, 2, 3, 4, 5, 6. Went up 6. So I'm going to do the same thing from this direction, from this point, which is my midpoint. So I'm going to count over 2. 1, 2. And up 6. 1, 2, 3, 4, 5, 6. Alright, it's kind of hard to tell where that's at. I counted over 2. And then I went up 6 from here. So 1, 2, 3, 4, 5, 6. So let's see where I'm at. What point is that? So x direction is 1, 2, 3, 4, 5. And my y value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Alright, let's double check that. So I've got my formula, x1 plus x2 over 2, and y1 plus y2 over 2. So I'm going to plug in my points here, so I got x1 is 1 plus an x I don't know over 2. That equals my x value of my midpoint. Multiply both sides by 2 so that those cancel out. I get 1 plus x2 equals 3 times 2, which is 6. If I subtract 1 from both sides, I get that my x value is equal to 6 minus 1, which is 5. Looking good so far. Now my y value is y1 plus y2 over 2, and that equals my y value of my midpoint. So my x1 is 1 plus the y I don't know over 2, and that equals my y value of my midpoint, which is 7. I'm going to multiply by 2 on both sides so that those cancel. I get 1 plus y2 equals, multiply both sides by 2. Where's my 2? Okay, so 7 times 2 is 14. Glad I caught that so early in the morning. Subtract 1 from both sides, and I get y2 equals 13. What? Yep, there's my point. Sure enough, 5, 13. You can do one way or the other. I don't care which one you do. Just take your time and do it right. Okay, and then the last one here, find the distance between 2 points. I can use the distance formula or Pythagorean theorem. I'm going to write the distance formula here. So I got 2 sets of parentheses with a plus sign in between it. Put squares on both and negatives on both. Then I got my Pythagorean theorem. A squared plus b squared equals c squared. Alright, so I got my 2 points. Find the distance between it. I got my x value, x1, my y1, my x2, my y2. So if I plug those into the distance formula, I get, I'm just going to rewrite it. No, I'm not. I'm going to plug it in. So I got my x2 minus my x1. I get my y2 minus my y1. Let's see what I get. I'm going to do what's inside the parentheses first. So what is 4 minus 1? That's 3. What's 2 minus 4? That's negative 2. So that gives me 9 plus negative 2 squared is 4. That gives me the square root of 13. Woo! If I use Pythagorean theorem, I'm going to graph these. 1, 1, 2, 3, 4. That's A. And B is 4, 2. 1, 2, 3, 4, up 2. So I have a triangle where this is 2, and that is 1, 2, 3. If you wasn't sure about the 2, you count it, 1, 2. So I get a squared plus b squared equals c squared. So 2 squared is 4, plus 3 squared is 9. That equals c squared. Square root it. And guess what we get? The exact same thing, square root of 13. 4 plus 9, square root of 13. Alright, so if I'm going to use Pythagorean theorem first on this one. So I've got negative 1, negative 5. Then I've got 3, negative 2. So I've got a triangle. So if I count 1, 2, 3, count over 1, 2, 3, 4. Oh, I love these numbers already, because I know when I plug them in, I've got 3 squared plus 4 squared equals c squared. That's 9 plus 4 squared, which is 16, equals c squared. That's 25 equals c squared. If I square root it, c equals 5. I knew that was on its way, so I'm happy about that. Then I can use the distance formula. I've got my x1, y1, my x2, y2. Put my minus signs in there before I forget. I've got x2, which is 3, minus x1. Then I've got my y2 minus my y1. Lots of negatives there. Negative negative is a positive. Negative negative is a positive. So square root of 3 plus 1 is 4 squared. plus, then I got negative 2 plus 5. That gives me 3 squared. Looks pretty similar to the Pythagorean Theorem I've got over here. So I got 4 squared is 16, 3 squared is 9. That's the square root of 25, which I know is 5. What? There we go. All right. Get ready.